Hello everyone. Last lecture it has been stopped with this supernetting. Now let's continue this. So actually this supernetting, it is a process of combining or aggregating multiple subnetworks to form a supernetwork or a complete network. In subnet, we divided the network in subnetwork. Here we are just aggregating all the subnetwork to form a global network. And this technique is almost obsolete now. That is, we are not using this technique in this modern internet because of replacement by classless addressing, which have subnets as well as prefixed notation called CIDR, which we will discuss in the forthcoming slides. And this term was coined to describe the act of combining multiple classful networks. That is, it was coined during the era of classful addressing to satisfy huge demand for mid-size organization which needs more addresses. So this is the main purpose of the supernetting. That is, an organization can combine several class C blocks to create a larger range of addressing. So as I said, this technique is not used now. It is replaced by this classless addressing. So before seeing classless addressing, we'll see what is a problem with then existed classful addressing. So that problem is known as address depletion. Address depletion means due to the growth of number of devices on the internet, these classful addresses are almost depleted, which means they are almost exhausted. That is, they are reduced in number. So the number of devices on the internet is less than 2 power 32 address space. So instead of this classful addressing, we are moving on to this classless addressing. So in classless addressing, there is no such classification of addresses. Instead, the addresses is supplied as an address blocks. So in address block, all the small, mid-size, large entities are given a range of addresses known as block. Example, here you can see an house. For household purposes, it may be given only two addresses, whereas an ISP is provided with some thousands of addresses. So based on the customer need. So here there are three restrictions for using this classless addressing. That is, the address in a block must be contiguous one after the another. The next one is the number of address in a block must be a power of 2. The first address must be evenly divisible by the number of addresses. Now let's see an example with SATA and we'll check whether it satisfies these three restrictions of classless address block. In this example, the block of addresses are represented both in binary as well as in dotted decimal notation. Now let's check whether the rules are check with the rules or restriction of this address block. As we see, the first rule is the address in the block must be contiguous, that is, it must be continuous. Here you can see there are some 16 addresses and all these addresses are continuous. So the first property is satisfied. And the next restriction is the number of addresses in the block must be power of 2. Here, when you count the number of addresses from this particular address to this particular address, the total number of addresses is 16. Again, it is a power of 2, that is 2 power 4. And the third rule is the first address must be evenly divisible by the number of addresses. So when you divide this addresses by 16, it satisfies this property. That is, the first address is divisible by 16. So you can say this particular address block is a classless address domain. The next term related with this logical addressing is network address translation, that is NAT. Nowadays, the number of internet users have increased and it is still increasing. Earlier, we used internet using dial-up connection. That is, we use phone line to connect to ISP, that is internet service provider, and we connect to the internet through ISP server modem. The data transfer speed of that dial-up connection is only 56 kbps, which dynamically give addresses to the user when they are needed. But now only 3% of users use dial-up, and it is overcome by broadband connection, which saves time, money, and it is more convenient. And now the internet is being used from a home to small business, or even to the larger business, and several hosts and routers need to be connected, and obviously it need IP addresses. So this shortage of addresses is overcome by a process or technique called network address translation. It is an internet. The definition of this NAT is it enables the user or the LAN to use one set of IP addresses, which is a large set of addresses for internal traffic, and to use a second set of addresses, a small set of addresses, to handle the external traffic. The purpose of doing so is this NAT acts as a firewall, that is, by hiding the internal IP addresses. And also it enables a company to use more internal IP addresses. Since when used internally, no conflict of IP address used by other companies or organization. In this figure, the Internet Authorities, that is IANA, have reserved these three sets of addresses as private addresses. That is, this table shows the addresses that are unique inside the organization but not globally. The site must have only one single connection to the global internet through the router, and that runs the NAT software. Which means in this figure it shows a NAT implementation of private network which uses private addresses. That is, the router that connects to the global network uses one private network as well as one global network. So the global network or the internet sees only the NAT router via this global address 200.24.5.8. So in this example, all the outgoing packet will be passed through this NAT router. That is, the source address is replaced by this global NAT address. So this is a source address. When it is going outside, it is replaced by this NAT router address. And all the incoming packets similarly pass through this NAT router. So this is an incoming packets. And here the incoming address is replaced by the appropriate private address. So this is a private. So while going outside, it is replaced by this global NAT address, and when it is coming inside, it is replaced by the private addresses. And it uses this translation table, that is for dispatching the data to the correct destination addresses. To do so, it uses two type of method, using either one IP address or using the pool of IP address. So in one IP address, the transition table has only two columns, private address as well as the external address, which is the destination address of the packet. Now let's see an example so that you can get the clear understanding of this translation table. Now let's see how the address translation is done in this example. So here in this example, the NAT router box address is 200.24.5.8, okay, as per the previous example. And the source address of the incoming packet is this 172.18.3.1, and the destination address of destination address where the packet goes is 25.8.2.10. So this is a thing. So here I have missed 0. You just put 0 over here. Here in this translation method, when the router translate the source of the outgoing packet, what is the source of the outgoing packet? Source address, so this address. So actually this source data will be transferred through only this router, which means this address is converted into this router address to get connected to the global network. So when the router translate the source of the outgoing packet, that is 172.18.3.1 to 200.24.5.8, it also, why it is translating, because it goes to this router, so this address is translated to this NAT router box address. So while doing so, it also make note of the destination address where the packet is going. Okay, the destination address is this. So now when the response or acknowledgement comes from the destination addresses, the NAT router box address, that is what is NAT router box address, this address, right, 200.24.5.8. Here the router uses the destination address which is already stored of the incoming packet as a source address, that is 25.8.2.10, to find the private address of the packet. That is when it receives the incoming data, or when the incoming responses, it just look on to the addresses, external addresses which is already stored while translating this private address to the global address. So this address is act as a source address in this private network. Why it acts as a source address means, because of this address we can able to identify the destination of the incoming packet. So the destination of the incoming packet is this, because the data has been sent from this address, so the acknowledgement has to be received to this address. So in this mechanism, the communication is initiated by private network, that is customer side, using all the protocols like HTTP, FTP or Telnet to access the server. So here, instead of using one IP address, the NAT router can use pool of global addresses. That is, instead of using one global address, in previous example you have seen 200.24.5.8, the NAT router can use 4 addresses from 200.24.5.8 to 11. So the 4 private network hosts can communicate with the same external host for efficient transmission. So this allows the many-to-many relationship between the private network host and external server program, which means in this table, that is in this table of pool of IP addresses, 2 hosts with an address of 172.18.3.1 and another addresses of 172.18.3.2 inside the private network can access the external host, which is the 25.8.3.2, using the port number as well as an IP address, which is known as the socket. Thank you for listening. Please visit my next lecture, which is about masking and CIDR.